When it comes to Wi-Fi design, there's two types of survey. There's a predictive survey and a validation survey. With a predictive survey, we use a software called EkaHau Pro. This allows us to import a scaled floor plan and virtually place access points on the map based on the customer's requirements. So with EkaHau Pro predictive surveys, we're trying to simulate how an access point will perform based on the construction type of the walls within the floor plan. EkaHau allows us to draw walls on the floor plan based on different construction types. Everything from concrete walls, block walls, stud walls, glass. And this allows us to accurately place the Wi-Fi access points based on the customer's requirements. So this is EkaHau Pro. So this is the software where we will do our predictive Wi-Fi design. First of all, we're just going to add our floor plan. So we choose this option to add map. So here we just have a typical floor plan of a standard office. And what we need to do first is set the scale. So we can see on the floor plan here, it's just under 2 meters, 1.9. So I'm going to add my measurement in here and I'm going to type in 1.9 meters. So this sets the plan, the scale of the floor plan based on the measurements to give us an accurate representation of where the access points need to go. So next of all, we need to draw our walls. So the walls need to replicate the construction of the actual office itself. So typically we would do an on-site survey for this to verify, but we're just going to assume for the moment that these are drywall. So again, we're just going to draw these walls in. For the outside of the building, we are going to use the concrete as for the external wall. So as you can see here, we've got multiple different default options to choose from, and each option has a different attenuation value. So this impacts on how the Wi-Fi signal strength actually penetrates through walls. So for the office doors, we're just going to choose a hollow wood, an interior door. So now that we've drawn all our walls in, we're just going to simply add our access points in. So I'm going to choose an access point that we would use quite frequently. It's from a company called Cisco Meraki, so it's the MR33. So we choose our access point and we place the access points on the floor plan to give us a visual of the signal strength that the access point is producing. So we can see when we hover over the access point, it actually gives us a signal strength. So what we're looking for is this value down here is minus 67 dBm. So we can see we are getting this throughout the majority of the building, but over on the right hand side, there are some grey spots. So we're simply going to add a second access point over this side of the building. So now we can see we have complete coverage of the building on the insides, and we can check additional values such as network health, which is currently failing, as both Wi-Fi access points are actually currently on the same channel. So what we can do up here is we can actually adjust using our channel planner. And it's also failing based on not having enough Wi-Fi access points, so our secondary signal strength. We also have the option of automatically placing Wi-Fi access points. So first of all, we just need to define our requirement area. So the requirement area is obviously the complete floor plan. then we would use the auto planner. So we're going to use the EkaHau best practices, which is the values that would be a best practice from EkaHau themselves. So if I choose both here. So again, the access point we're using is the Meraki MR33, and we're just going to choose Create Plan. So this has been a brief introduction to the EkaHau Pro software doing a predictive design. For more information on EkaHau, please go to our website or contact a member of staff.